So we're solving this question on vectors, which says that the lines L and M have vector equations given by these two equations. Lines L and M intersect at the point P. State the coordinates of P. Okay, so to find the point of intersection, we equate the two lines equations. So we write, this would be, the first one is 2, 1, minus 3 plus lambda minus 1, 0, 2 equals to 2, 1 minus 3 plus mu 2 minus 1, 5. Now you form three simultaneous equations from this and solve the first two to find the value of lambda or mu. Okay, this would be 2 minus lambda equals 2 plus 2 mu, which would just be negative lambda is equals to 2 mu or lambda is equals to minus 2 mu. Call this equation number 1. Second one is 1 plus 0 equals 1 minus mu. That gives us mu equals 0. And that gives us lambda is equals to 0 as well. So when we substitute it back in any one of these equations, that gives us 1, 2, 1, and minus 3. So the point of intersection would be whether you use lambda is equals to 0, then you use this equation, or if you use mu is equals to 0, then you use this equation. But in both cases, our position vector is going to be 2, 1, minus 3. But we need to write that in the form of coordinates. So we write P 2, 1, minus 3. Okay, that is part A. For part B, we have to find the exact value of cosine of the acute angle between these two. So we have to find cos theta of their direction vectors, which are these. So minus 1, 0, 2 dot 2 minus 1, 5. In the denominator, we write the magnitude. So that's going to be square root 1 square plus 0 square plus 2 square. That's a 5. So square root of 5. And for the other one, it's 2 square plus 1 square plus 5 square inside a square root. That would be a 30. Find the dot product in the numerator. We have minus 2 plus 0 plus 10. That's an 8. Now find cos inverse of this. No, in fact, we just have to find cos theta. Find the exact value of the cos of the acute angle. Okay, 8, and what's under root 5 times under root 30? That's 5 under root 6. So we are getting 8 upon 5 under root 6. And if you would like to rationalize it, let me just enter it in the calculator. 8 upon 5 under root 6 is 4 under root 6 over 50. That's the simplest answer for part B. Part C, point A on the line L has coordinates 0, 1, 1. Point B on the line M has coordinates 0, 2, minus A. Find the exact area of triangles A, P, B. So, we need the area of triangle APB. Let me try drawing that. Let's say this is A, P, and B. All right. We already have the angle between them because we're told that point A lies on line L. So this could be line L. and point B lies on the line M. So this would be the line M, and we already have the point of intersection, which is 2, 1, minus 3. So that's 2, 1, and minus 3. And we also have OA and OB. In fact, let me just write them all together. So we already know OA is 0, 1, 1. OB is 0, 2, minus 8. And OP is 2, 1, negative 3. All right. So we also have cos theta of. So what we'll do first, we'll find this length by taking the magnitude of AP. Then we'll find this length by taking the magnitude of PB. And then we can use for the formula half times AB sine C. And we'll need the sine of theta. Right now, from the last part, we have cos of theta. So let's get started. Okay. First of all, I need AP. AP would be OP minus OA. So that's a 2, and then that's a 0, and that's a negative 4. And let's find its magnitude. Magnitude is going to be square root 2 square plus 0 square plus 4 square. That's under root 20. Zero, 1, 1, and I'm sorry, that was OP. So did I subtract OP from OA? I might not have. Wait a second. It is correct, under root 20. So under root 20 is correct. Okay. Next, we need the magnitude of PB. So first we find PB, which is OB minus OP. So let's subtract those. That would be 0 minus 2 minus 2, 2 minus 1, 1, and then negative 8 plus 3, 5. Now let's find the magnitude, which is going to be square root of 2 square plus 1 square plus 5 square, which gives square root of 30. So I know this side is square root of 20 in magnitude, and the other side is square root of 30 in magnitude. And now I need sine of the angle in the middle. For that, what I'll do, I'll already have cos theta. So since cos theta is already known, cos theta is 4 under root 6 over 15. I find sine square theta from 1 minus cos square theta, and then I'll under root that. So 1 minus 4 under root 6 upon 15 squared, and then under root this. So that will give us the value for sine theta. So let's first square that. Fraction key 4 under root 6 upon 15 whole squared. That gives me 32 upon 75. 1 minus answer. That gives me 43 upon 75. So square root of 43 upon 75. So let's now use half AB sine C. So half times under root 20 times under root 30 times sine of the angle in their middle, which is square root of 43 upon 75. Now let's multiply all of these together and see what do we get. Sorry, that was a 20, not a 2. So we get half into, take the square root common, inside write 20 times 30 times 43 upon 75. If you do that, do each step separately, what your calculator will do is give you a decimal answer. Now this gives me 344, half square root 344. And when I multiply half with square root of 344, that gives me under root 86, which is the exact area.